Hello, today I will present my yearly project, which has a topic Arrow's Impossibility Theorem, which is about the flaws of the voting system we use in general, through tables, diagrams, and graphics, illustrating the flaws of it. What is Arrow's Impossibility Theorem? Arrow's Impossibility Theorem, or Arrow's Paradox, is an impossible theorem in our social choice theory, which states when there are three or more alternatives for voters, no ranked voting electoral system can change the ranked preferences of persons into a community-wide ranking while also meeting a specified set of criteria: unrestricted domain, non-dictatorship, Pareto efficiency, and independence of irrelevant alternatives. And the theorem is named after Kenneth Arrow, trying to depict an image for us to see the social choice paradox, illustrating the flaws of the modern and current ranked voting system. Some people's preferences will influence this decision. Hence, the question is what processes exist for determining a collective or social ranking of the options from better to worse based on what is known or discoverable about their preferences. This begged the question in Kenneth Arrow's mind, which led to the foundation and discovery of Arrow's impossible theorem, also known as Arrow's paradox. Today, in our daily life, there are still multiple countries that use democratic political voting system, which leads to where Arrow's impossible theorem originates from. We may think that democracy grants us the most honest possible choice in voting, but it unfortunately does not, because the voting will be flawed considering there are always three or more choices in a voting, especially in the choosing of a president of a country. Arrow's theorem also persuades people to create a better voting system, which is very different from the current one we use, because its flaws only allows us to do simple levels of voting, which becomes useless over time. Proof of Arrow's impossibility theorem. Arrow's impossible theorem is usually depicted through formalism instead of the usual graphical representation in most mathematical depictions of it, but there are still several ways to depict it through graphics, diagrams, and tables. To explain a simplified version of Arrow's impossibility theorem, we can suppose that V have a group of voters which will be determined by V, which will vote for a president or any other type of social leader. For example, V1, V2, V3, and so on. And also an arrangement of social leaders which will be determined by L, for example, L1, L2, L3, and so on. And R symbolizes all the possible arrangements, preference orderings over L. Depending on these groups, Arrow's impossibility theorem states that Ln bigger or equal to L3 and Vn bigger or equal to V2, there isn't any voting function. So I have turned these numbers into a graphical function, and this graphical function states the functional part of our voting system, which is depicted through x and y. Frn to R that satisfies Pareto efficiency, independence of irrelevant alternatives, unrestricted domain, and non-dictatorship. As I did before, and now for graphical representation of Arrow's impossible theorem, we can create a scenario with three different voters with different opinions from one another. Voter A states their selection with X or Y over Z. Voter B states their selection with Z or X or Y. Voter C states their selection with X or Z or Y. The table of these voters' candidates and the rankings can be seen here, and so I turned these options and voters and the table to a graph to show the difference between opinions and how they cross each other, but they still cannot get into one well, opinion for the community's great and the well-being. Okay, so now that we have given our voter selections, we will again state the four main qualities that we want in a voting system: Pareto efficiency, independence of irrelevant alternatives, unrestricted domain, and non-dictatorship. Unfortunately, it is impossible to check out all four main qualities of a perfect voting system. For Pareto efficiency, for voting with a huge amount of voters cannot be dependable to choose an optimal level of Pareto efficiency, because there will always be a ranking where there is a better social leader than the other one. But the huge amount of votes will be in the section will always pick somebody worse than the best, even if it's a singular vote, for a worse president. So that is why Pareto efficiency is not achievable in democracy. For non-dictatorship, technically, the use of dictatorship would disapprove Arrow's impossible theorem if it didn't violate the non-dictatorship rule. In a dictatorship, only a singular person controls the whole government, and every person in the government has to do whatever a dictator asks them to do. For the independence of irrelevant alternatives, let's set preference for leaders as X, Y, Z according to our voter A. Let's say there's a fourth option, V is added to candidates. Now that we have added our fourth option, the voter A's preference become V over Y over X over Z, depicting us that adding a fourth option has a chance to disrupt the order of X over Y over Z. If there's a fourth option added, thus, once again, providing Arrow's impossible theorem. So it can be seen that when we add V to the graph, it disrupts the straight line, which normally the voter A had like this. And now it becomes more of a graph instead of a straight line, through the y-axis having the rankings and the x-axis having options, showing the rankings versus options for this independence of irrelevant alternatives part of the rule theorem. For an unrestricted domain to work, every voter must have a unique preference and a full ranking for their choice of social leader. Let's say there are 6 social leaders and candidates for an election that will make 6 factorial, which is equal to 720 different possible rankings amongst the voters, but it is geometrically impossible to build both a voter and candidate arrangement to add on to the problem of an unrestricted domain elections which involve more than 101 distinct ballots, meaning at least 86% of ballots, which is shown here in the graph, will never emerge in any voter candidate arrangements. And the 14%, which is the 161, is shown in here at only the 14% of all of the ballots, which can be seen with this graph named percentages of votes versus types of ballots. Conclusion on Arrow's impossibility theorem. Through these explanations of 4 main qualities of Arrow's impossibility theorem, I have depicted you the fact that it is impossible to create any sensible voting system from what we have now that will check out all of the rules of Arrow's impossibility theorem. And since Arrow has made this theory, there has been a lot of theoretical voting systems that have been created that may be seen absurd in today's society. Even though they are absurd, they unfortunately have yet to check out all the boxes in the part of Arrow's impossible theorem, because checking one of the rules out contradicts the other ones, which leads to the impossibility part of the theorem. The reason we use democracy is to at least give voters a free will, or maybe an illusion of free will, because there are not many candidates to choose from, which makes it so that the candidate you choose may not be even fit for you or other people, but you still vote for it because you must make a choice. So this is why almost all of the countries in the world use democracy. Unfortunately, in our world, we cannot ignore Arrow's impossible theorem to make the best voting system possible. But maybe someday somebody will be able to break Arrow's impossible theorem and prove him wrong. Thanks for listening to me.